Good morning, everyone. Thank you for joining us for our open mic session on HCL OneTest Performance, Jumpstart Your Transition from Apache JMeter to HCL OneTest Performance. My name is Kim Splain. I'll be your moderator today. I'd like to go over just a couple quick housekeeping items before we get started. First of all, the session is being recorded, so if you prefer not to participate in the recorded session, please go ahead and drop from the call now. And then during the webinar, we'd like to ask you to type your questions in the question box in the GoToWebinar control panel, and one of our team members will respond as soon as possible. And then as time permits, we'll take a minute to review some of the questions that came in during the presentation at the end. So thanks again for taking the time to join us today. We hope you enjoy the webinar. Now I'm going to hand things over to Arun Cuddy to get us started. Arun?
Thank you, Kim. All right, so welcome everyone. My name is Arun Kuti. I'm from the HCL OneTest Product Engineering team. And the topic for our discussion today is going to be how to jumpstart your transition from JMeter to HCL OneTest Performance. Now, we are familiar with this old axiom that change is the only constant in life, right? Thanks to the internet, we don't know who we can attribute this code to any longer, but at least we all are convinced of its veracity. Now, this is especially true for folks like us who are working in the software engineering industry, and regardless of our domain and our role that we are working on, we are always exposed to some kind of change in some form or the other. Now, as performance testers or performance engineers, none of us are strangers to this fact too. Things keep changing. All right, so what is good with the changes occurring is that whether we are aware of this or not, our learning is always a process of an associative process, right? So we always learn new concepts by relating it together with stuff that we already know. So this always happens regardless of whether we are aware of it or not. So many a times our experience with our experience in a domain is going to help us to learn new things that we encounter as we go ahead in our journey in that domain. Now, while it is a fact that our experience is something that we can leverage in order to stay current, at the same time, there is always this possibility that changes are met with some kind of friction, right? Now, by the term friction, what I refer to is the combination of notions that are invalid, sometimes cognitive biases that can occur, or sometimes even simple plain inertia, right? Because of the unfamiliarity of whatever's new in front of us, we might face some inertia. So these are what we can call as thinking traps. So what happens is, due to all of this, gaining new insights when a change is thrust upon us, especially in a field of our known expertise, is sometimes not going to be a walk in the park. Right now, there is a great case in point here when it comes to a new user of a tool like HCL OneTest Performance starts working with OneTest Performance after being well versed with a different tool like Apache JMeter. Right, in this day and age, if for a person who is let's say been working in this industry for the last decade or so, chances are that they would have got started, or their experience with performance testing would have started with Apache JMeter. Right, that's due to the fact that it's open source, it's out there, it's ubiquitous, it's free, and all of that stuff. So it makes it like a candidate for people to take up first as soon as they start doing test automation or performance testing. Now, once you become well versed with a tool like JMeter, what happens is you start thinking in certain patterns, right? You start garnering certain biases out of your use of JMeter, and these do not augur well when you try to move to a different, adopt a different tool for your work. And it's very likely that once you get into an enterprise, into the enterprise world, once you start working with, low testing of production applications and stuff like that, chances are that you'll start working with an enterprise tool like HCL OneTest Performance. So the idea here is that we discuss some of those differences that you might encounter, which might puzzle you at the beginning, and look at what is behind, right? What drives those differences? What are the factors that influence those differences? And then try to understand them and then to get a feeling for how certain things are the way they are with OneTest performance as compared with JMeter. And then you use that new light as a catalyst for a mindset change, right? And then the idea here is that, what we need to get to happen here is a mindset change. Now, the topic is really vast. If you were to compare each tool, like each nitty-gritty one at a time, we're not going to cover everything of it like in one session. Not even like even if you spend months in tutorials, it's not possible because of the vastness of this topic. So what we're going to resort to here is to look at certain key differences, understand them, and then use that understanding as you continue with your exploration, right? So the outcome or the objective of this session basically is what we think a mindset change. Now, one other thing that I wanted to point out at this point is that this talk is basically distilled out of our team's experience handling concerns and issues and questions coming in from new adopters of HCL OneTest performance who are like well versed with Apache JMeter, right? So we've basically been having our internal discussions going through all of that, and then I've tried to condense all of that into this session here, right? So that's what basically this talk is all about. That said, let's quickly move to the agenda for this session. So we started off with the introduction. I already covered it, what the session is all about and what the end objective of the session is going to be. And the next set of slides is going to be on what the methodology for this particular session is going to be, right? So what's the strategy that we're going to use on how this session is delivered, and certain central themes or central differences between these two tools, which we are going to use as our anchor for the rest of the discussion. So once we cover the preamble part of it, we're going to move to all three aspects of your test automation, which is your test creation, test execution, and finally reports and analysis. And then we finally have, as Kim was mentioning, we'll have some time to discuss questions if they emerge. We'll try to cover, we'll do our best to cover the questions, and if the time is wanting, if you want to spend some more time on it, what we can do is use the question answers forum, which I've linked in the references. We can continue our conversations over there. Now, the way we have split time across these is to spend the first 5-10 minutes discussing about the methodology and central themes, and then take 10 minutes to talk about test scripts, 10 minutes to talk about test execution, and then spend about 25 to 30 minutes with reports and analysis. And then we should leave. I anticipate my talking to get over like in an hour and a quarter. So we should have about 15 minutes of time for discussion. Now, coming to the methodology for this particular session, right? So our focus is going to be on HTTPS protocol and the extensions that are revolving around it for both tools. For obvious reasons, HTTP is by far the most popular protocol that makes up the web as we know it today. Both tools are good with HTTP, so it makes sense to explore the features and explore the differences, keeping HTTP protocol in mind. The bulk of our content delivery today is going to happen through walkthroughs of these tools. So I'm going to open up, show you things as how they work in OneTest performance, and then show you how things work, the equivalent stuff, basically the other way around, right? So I'll start showing you content on JMeter and then show you what the equivalent of that in OneTest performance is going to be. I hope their experience is not going to be very jarring because of our familiarity with all these tools, right? At least to a little extent, we know what each tool is, so we should be able to go through this smoothly. Now, as a sample scenario, since we are talking about test automation here, we need to have a sample scenario. So what we're going to use as a sample scenario for our session today is a sample application that comes with the Spring framework. It's called Pet Clinic. So I'm going to take a quick excursion here to show you what this application looks like. So have it running in localhost, listening at port 8080. So a simple home web page is launched. You have some pictures, some stuff that's going on this page, and then you have some navigation items. So the specific scenario that we will look at is, a find honors flow. So you click on this navigation item here, and you search for a last name, and you do a fetch, and then you get some details coming out for that particular entity, right? So this is our sample scenario that we want to work with in our scripting and execution and analysis and everything. Quite simple, but it's not simplistic in a way that it is sufficient to show you all the features at work, right? At the same time, it is not overly complex and overwhelming. So that's with our sample scenario. I'm going to take this out of here. And then one other thing that we're going to resort to in this particular session is that we are going to minimize all external plugins and external customization and bells and whistles and all that. And instead, we're going to focus on what the core of each product are going to give you. All right. Now, this is especially valid in the case of Apache JMeter, because Apache JMeter, as you know, comes with a light core and with a heavy extensibility, right? It comes bundled with a plugins manager, which you can use to shop around for plugins and do all that kind of stuff. So we're going to avoid all of that and just look at what comes with the core of the product and use that for our session, for our discussion. All right, I'm using Apache JMeter version 5.2.1 and OneTest Performance version 10.2.1. So this is for your information. Now moving on. So here are the key thematic differences between these two tools, right? Now the way these emerged is out of our team's use of these two tools over a period of time. So that's how we've gotten to these ideas as to how these tools differ in terms of their philosophical differences. Now, these differences may not come forth to a user as soon as they start using these two products, right? It takes some time for them to emerge and for you to start appreciating what one tool does versus the other. So here, as an experiment, in order to jumpstart your transition, right? The idea here is to bring forth all these philosophical differences, put that right in front of you, give you some examples as to what each of those differences are, some live differences, right, as demos out here in this session, so that you can use those as continued, to refer back whenever you go back and start looking at other features of the tool. You always have something to tie that back to. So in that way, you can jumpstart your learning experience with HCL OneTest Performance. So that's basically the experiment that we are proposing through this session. Now, each of these philosophical differences between these tools are important to keep in mind. So I would invite you to have all your attention on this slide at this point. And let us briefly talk about what each of these differences are. Now, first off, what is a philosophical difference between a tool, right? What's the philosophy of a tool anyway, right? So I will define philosophy of a tool as that net set of beliefs, principles, and values that drive the builders to build the tool, right? That's whatever shapes up the decision making for the tool. So it's kind of a North Star, or kind of a compass for how the direction for the tool is set, right? And that's always there in the behind of each and every builder of this tool, right? Now, in terms of the first and foremost difference between these two tools in terms of their philosophy is that OneTest Performance basically sees itself as an entire standalone end-to-end product, right? So all the tech stack that you need for your performance testing is all plugged into it already. It's a standalone product. Versus if you look at Apache JMeter, its ambitions to work as a tool which is a significant part of a larger solution. All right. So this is the first philosophical difference between these two tools. Now, the second is that the OneTest Performance comes up with an audacious goal of making you productive on day one if you're a novice performance tester. All right. Whereas JMeter assumes that you have certain expertise already in scripting and all the other levels of work that is required for your performance testing. The third point is that JMeter basically aims at simplicity, whereas OneTest Performance basically aims at fidelity. Now, when I say simplicity, I don't refer to it in a derisive manner. I don't refer to it as naive, but what I instead think of is that it is built upon the premise of keeping stuff simple and easy, and behaviors ought to be the most simplistic behaviors that you get out of a script. And then for more added complexity, you have to put in added work onto each script in order to build in complexity to it. So we're going to see how this plays out as we look at these examples. Whereas OneTest Performance, the focus is on fidelity. Now, what fidelity means is basically faithfulness, right? So the meaning of the term is faithfulness. So what we are trying to be faithful to is how a real user would experience performance. So our entire scripting and all the gamut of features of OneTest Performance is built towards giving fidelity. All right, and the last is something that we already touched upon previously. It's that most of the things that you get out of OneTest Performance comes out of box, whereas JMeter relies heavily on extensibility. So these are the key philosophical differences. So let me reiterate. These are given here as some anchors for our continued discussion in the session. So we're going to look at each difference in each section of our discussion. We're going to tie them back to what we see here as philosophical differences, right? And then you can have them hold on to them on your brain as you go forward exploring these tools and basically aid you for further retention as well as reflection. So that's the point of putting these philosophical differences here. So with that, we come to the first part of our the technical content, and that's on test creation. So we already went over the sample scenario. Now let us look at how that scenario looks like in JMeter, right? So as you remember, we launched the application and then we did a find honor. So what we have here in the JMeter script is basically a listing of all the requests that went between the browser and the end application, listed one after the other. And the entire list of requests that went into the home page, right? So they are listed under an entity called a transaction controller. So this is basically what you have in mind as something called a transaction. And the second transaction here is something called it's the pet clinic find honor transaction. And that's basically the second set of requests that you send to the application, right? So you have two transactions in your script. Oh, now before moving into more details, let me tell you how we capture these scripts, right? So if you look at JMeter, the way we capture this request is through a proxy recorder, and you must be already familiar of it. Use a recording sampler, you create it, and once they create that, your script gets a recorder inserted into it, right? Then you start it off, specify a port, and then what you have to do next is to manually open up a browser, configure the browser with the port, with the proxy details that you see here. If you're trying to access a secure application, you have to import the recorder's certificate from JMeter. JMeter gives you the path to collect it from, but you have to take it, explicitly add it onto the browser's trusted root store. So all these steps are supposed to be done manually. All right, so this is how you record your test, and this is how your script is going to look like. We're going to go into some more details pretty soon. In the meanwhile, let me bring in OneTest Performance as well. And you have the equivalent test script. This is created with OneTest Performance over here. The script kind of looks similar to what we have with JMeter in terms of structure, but there are certain differences here that we're going to get into in a brief while. But in the meantime, let me talk about how we create a new test script with OneTest Performance, right? So in order to create a new test, so what we do is inside your project, you start by using a recording wizard and select, the test type that you want to select. So once you do that, the recording wizard is going to guide you through the steps that is required for, basically creating the recording. But what is different, what is important to note with the OneTest Performance way of doing this is that the recording wizard guides you through all the steps, and then you don't have to do anything manual on the browser that comes out as an end result of finishing up the recording wizard. So all the setup, that is setting up the proxy server with accuracy, detecting the proxy details of your system if they have any, all of these things are done under the hood and done for you, automated for you, so that you don't have to worry about all of that. And also the installation of the secure certificate, right? So that also happens without you being aware of it. So it's all taken care of by the wizard, and it just takes you to the point of simply navigating through the application on the browser, right? So this is all, if you think about the philosophical differences between the tools, this difference is basically something that can be attributed to the day one productivity goal of OneTest performance. Okay, so once you have your test script recorded, it's pretty much going to look like this. I did modify the names of the pages so that it reflects what I had in mind for the transactions. And if you look at the test script, so this is where things start to get a little interesting. So first off, you see a few color codings sprayed across the test script, right? So if you wonder what those are, that is an end result of a process called automatic correlation, right? And automatic correlation is one other day one productivity feature that is built into OneTest performance. So if you think of automatic correlation, in order for you to understand what that means is, it becomes easier for you if I use the term parameterization, right? Because that's the term that JMeter users are more familiar with. So there are parts of your test data that is dynamic and that needs to be, substituted. You need to parameterize all of that, right? So a lot of those things are already done for you as far as generating a OneTest performance test script goes. Now, if you look at JMeter, on the contrary, you see that none of the parameterization has happened already. Now, there might be some other external plugins that could potentially do this for you, but that's again an involved process. You have to search around, you have to make sure that you get the right things and all of that. And for a start, I don't even know if that such a thing exists or not, right? But with OneTest performance, like clearly out of the box, you simply get this whole feature given for you, right? And let's look at what it does, right? So let's now examine the first request inside your inside the script. And if you look at it, you'll see there are multiple parts of your test request, which is pretty much similar like how Postman UI is or a SOAP UI is, right? And you have an aspect of your request called the connection. So if you click on the connection, it basically takes you to a part of your test script called the server access configurations, where all the application details that your application under test is made of is listed, right? And then you will see the host and port details are there. And sometimes your authentication, your SSL related information may be here. Sometimes if you have a proxy server to access it, that details will also be here, so on and so forth. But what's important here to note in this simple script here is that the host details have already been substituted, and which is what this purple color signify, right? Now let's see where it has been substituted from. So what we do is navigate from here and go to the place where it's been substituted from, and then you'll see here it's been substituted from a test variable, right? So now if you want to change this location of your application, right? Say tomorrow you're moving this application from this dev environment in your laptop and moving it to a lab machine, all that you have to do is to port the script would be to modify this variable here. All right. So most of the wiring that is required for this to be possible is already done for you. Whereas if you compare that with JMeter, that isn't done for you. So you have to manually go ahead and make this a variable and then add a variable, change its value, so on and so forth. The manual effort is reduced as far as even your HTTP request defaults go. Okay. Now, even more interestingly, if you look at the second transaction or page in the scenario, right, you would see that some part of the requests have a different kind of color here, right? And this light green tells you that this data is potentially dynamic, as in it's test data, right? Something that you want to drive to be different for each virtual user, right? You may want to substitute. Each virtual user shouldn't be searching for the same user, so on and so forth, right? So you basically do your substitutions with a data set kind of thing. So that also is automatically flagged out for you. All right. So that's something that you have to keep in mind. And finally, and most importantly, if requests contain dynamic data in it, right, you don't have to do anything for parameterizing it. So the script will automatically catch it for you. The test generation process will automatically catch it for you. And here, as an example, so we can see that the last request in this transaction has gone to a URL honors 11, which is basically the 11 here. Typically, it kind of stands out like a dynamic thing, right? It's some kind of an entity ID for a particular order that you're looking for. And what this basically has been substituted from is the response header that came as a response to the previous request where we searched for a particular last name. So this becomes important. You might be aware of this already, but this becomes important when you change the name, the last name from Vic to something else. Then there is nothing that you need to do for the script to fetch that new user that you're searching for. So this automatic correlation takes care of that as well. So this is the first major difference. If you look at the scripting side of things, you have it's an automatic correlation being done for you, which is something that you don't get with the core of JMeter, and you have to put manual effort to identify all those and set all of them up. Now, in addition to automatic correlation, please also be aware that there is the possibility of doing manual correlation. So if there is something that you need to, something that you think is not right with the way the automatic correlation created references and substitute them, you can always override it with your manual changes, right? Or if something was not done, for example, if some correlation was not done, you can use this test editor here, create references, substitute them, and all of that using the test editor GUI. But again, automatic correlation is something which is very handy, something that is already done for you and important for you to understand when you get into OneTest performance. And that's basically one of the day one productivity features that I was talking to you earlier about. Now, the second major difference when it comes to scripting itself, right, is something, again, very important to keep in mind. And that is that we were earlier referring to something called a transaction controller, right, in JMeter scripts. So a transaction in JMeter or in any load testing tool, right, what you have in mind as a user of the tool as a transaction is basically a containment of requests, right? A container where you have multiple requests put in, right? So you want to have some kind of aggregation of requests and some kind of metrics gathered on that aggregated level. So that's what you have in mind when you think about a transaction. Now, the equivalent in OneTest performance for HTTP is something called a page. All right, so I would like to drive this point once again. The equivalent of a transaction as far as the HTTP protocol extension goes with OneTest performance is something called a page. All right, it's if you look at the structure of the script here itself, this will become obvious to you that instead of a transaction controller, as you can see in JMeter being a containment of container of requests, you have a page being a container of requests. All right, so this is something that you want to keep in mind. And again, there is another entity called transaction in OneTest performance as well. So you can simply move pages to it if you wish to. If you want some additional aggregation of pages itself, right, or some simple requests kind of thing, then you do have an entity called a transaction. So let me at this point put this across that you might be tempted to use this, but unless you have real specific reason to use a transaction, right, something that you clearly have in mind as far as your testing goes, only if you have specific needs should you pick up transactions. Otherwise, you are good with a simple page, right? Now, when I say a simple page, that's basically a misnomer. It is not simple. It's basically got a whole lot of embedded fidelity into it, which we want to get into in one of the coming sections, which makes a page in an HTTP test more than what you think a transaction is, right? It's like a transaction plus, if you will. So we're going to get into the details of that pretty soon. Now, one last part that I wanted to talk about as far as scripting itself goes is, if you look at Apache JMeter, you see that all the requests are put inside your transaction controller with no order of priority, if you will. So there is basically no linkage between these resources, right? It's just everything is flat, unidimensional. All the requests are there inside it. That's it. Whereas in OneTest performance, you'll see that one particular request in each page is showing up in bold, right? So why is that so? So the reason why it appears in the editor as bold is because it has been marked as a primary request for that page. The primary request for a page is automatically detected by the tool during test generation using a couple of criteria, but it's basically the most important request for that page, right? It's most of the times you can think of, if you think of a sample scenario that we had, right? When you launched that home page, what you basically did was you launched, you pulled an HTML data from the server, right? So that's what initially happened if you look at what the browser did. And then the browser parsed the content of that and then looked at what other things need to be loaded, right? Style sheets and, images and stuff like that. And then based on that, it issued more requests back to the server, right? So in a lot of ways, what you can think of is the secondary requests in a page is all driven by what is in the primary request, right? And we can also think of it this way, that if the primary request fails, none of these secondary requests basically have any meaning, right? So let's say your application couldn't serve the main, the page that consists of the business logic, right? If you cannot deliver it, then what's the point of loading all the other things and getting numbers out of that entire, playback, right? So in order to eliminate all of that, there is this concept of primary request. And this request, just keep in mind that it is the most important request. It gives for multiple things. And one of the things is that, one of the lesser important things is that because of having a primary request, you get certain useful test editing shortcuts, right? If you want to disable, all the non-important requests, you can really do so using this dialog and so on and so forth. So it gives you for some test editing, shortcuts, right, if you will. And more importantly, as I was telling you, since your primary request is the most important request, what we basically use that for is to determine the health of a page, right? So if the primary request for a particular page fails to work, then we don't report the health for that page when you are playing. We don't report the metrics, that is, while we are playing that page during a load test run. All right. So just keep those two things in mind. And these are like aspects of, if you want to attribute this to what are the underlying thematic differences between the two tools, right? So this can be attributed to inbuilt fidelity, right? You want more realism out of your tool. So that's what this basically gives you. So with that, I pretty much cover all the test creation aspects of the differences that we were looking at, considering for this session. Let's now move on to execution part of it. Now, when you talk about execution of your test scripts, right, there are two major dimensions to it. The first initial cycles of your execution is going to be all about troubleshooting, right? It's all about modifying your tests, getting your parameterization right, making sure that your flaky tests are no longer flaky, and you get some robust playbacks out of it, right? You make sure that those scripts are going to do what it's supposed to do. So that's your initial dimension of your execution, the initial real concern of your execution. And the second part of your execution is the actual real load test. So once you have stable enough scripts, then your concern is now how you're going to do, your load testing. Now, as being a full, end-to-end standalone tool, OneTest Performance provides you with a lot of options for easy troubleshooting. All right. Now let's look at troubleshooting of scripts and see what options we have with JMeter as well as what we have with OneTest Performance. Now with JMeter, in order to look at responses, when you're trying to play back a script, if you want to look at what transpired during playback, right? What kind of requests were sent to the application, what kind of responses were received, you're going to have to look at a result stream that's associated with your test script. And then if you do a playback, you will see that all the requests, get added onto your results tree view, right? it's kind of a full dump of all the playbacks of the script that has happened ever since you opened the tool, kind of thing. So there is no way you can associate like one set of requests with one execution that you did. It kind of makes it hard to troubleshoot your incremental changes on scripts. Now, there are definitely ways to change this and write individual results to file and then clear a results tree once your test execution is done and so on. But it doesn't come out of box, right? You have to spend that manual effort in order to accomplish all of that. Whereas with OneTest Performance, you will see that each time you perform an execution of a script, you have a record of it, which is called a result, right? So for each execution, you have one request that corresponds with it. Now you can look at what transpired in that playback by looking at the test log, right? So the test log is a very powerful tool in order to see what kind of requests were sent to the server while you were playing back and what kind of responses were got. So if you encounter any errors, you should be able to quickly step through the test log and see what caused that error, right? Makes a lot of sense when you're on your initial test debugging cycles of your execution. And you can also do keep in mind that we have a tool called test compare with test, which basically gives you a WinMerge style of changes view as to what happened while executing and what is in the test. So this gives for a very easy way for you to troubleshoot your scripts should something go wrong. All right. So in this case, you can see there has been an error. So there are ways you can find out, what was different in the request that caused that error. All right. So just do keep in mind that you have a test log that is always associated with each playback that you have, and that's persisted onto your file system. So you can retrieve it at any point in time. Now, once you have converted your flaky scripts to robust ones, you have your rugged set of scripts that you need for your schedule execution, for your load testing, right? At that point in time, your focus turns into load testing, right? Now, if you look at JMeter, in order to increase your virtual user load, you have a thread group that is defined on the test script itself. So meaning to say, the requests that go into the application server, as well as the loading criteria, are both on the same entity, all right, on the same test plan. Whereas in OneTest Performance, you have a different entity called schedule, all right. So it's like separating out of concerns in order to encourage modularity. OneTest Performance mandates you to create a new entity called schedule, onto which you'll have to add the test scripts that make up your scenario, right? So this way, your scripting concerns and your scheduling concerns are separated out. And this basically makes it easy when you are moving on to higher complex stuff, which invariably you will have to as you move on with your test project, right? So this basically makes it easy to manage, keep these two things separate. Now, I'm pretty sure that there should be a way to insert a script into another script in JMeter, which can kind of mimic what a schedule does in OneTest Performance. But again, that best practice is not built into Apache JMeter, whereas that is built into OneTest Performance. So this is one other difference that you can put into the product versus tool paradigm that we have been discussing, right? So the separation of concerns. So this is what you have to have in mind. Now, there are two different types of schedules in OneTest Performance. It's a virtual user schedule and a rate schedule. In a virtual user schedule, the loading is done by specifying the virtual users. So the loading is on the basis of users, whereas with a rate schedule, the loading is going to be on the basis of rates. So you specify a rate per second for hitting pages or transactions, samples, or whatever it is. So you specify that, and the tool will automatically adjust the user load that can have you achieve it. All right. So we're going to look at the view schedule here. So in this schedule, we have three different stages, right? So the stage is also maybe a concept that you haven't come across in JMeter. That's like inside the same schedule, there are periods of time when you can run it with one set of users and then increase the user load to another set of users and then finally come down or whatever you want to do, right? So you can specify that in your on the user load specification of your BU schedule. Now, there is always this question as to how do you control the ramp up and ramp down rates. So I thought it would be a good idea to briefly touch upon that. So once you check this box called Show Advanced, you will start seeing two new columns that appear on your user load specification dialog, right? And that basically, one of them is your change rate. Now, a global term called change rate is used to signify both ramp up and ramp down, right? Now, how does this same setting work as both ramp up and ramp down at the same time, right? So how does it accomplish that? So this is done by looking at the beginning of each stage, right? So if your net number of users in your current stage is going to be more than what was on the previous stage, then the change rate is going to act as a ramp up rate. So if you look at the first stage here, your schedule when you started it initially, it starts with 0, right? So there aren't any users. You inject 5 users on this stage. So since it is a net addition of 5 users, this 1 in 5 seconds in this first row is going to act as a ramp up rate. Now, after the end of the 5th minute, you're going to get into the second stage where the user load is specified as 10, right? So at this point, you already have 5 users running on your system. Now you're going to increase that load to 10, and that's a net increase of 5, right? So an existing 5 more to get it to 10. So this change rate in this stage acts as a ramp up again because it's a net increase. Now at the end of 5 minutes, you want to stop your schedule run on a gradual fashion, right? You don't want all the users to exit at the same time. If you have that requirement, what you need to do is set up a final nominal stage of, let's say, a minute, and then specify a change rate of whatever you need as the ramp as a change rate over there. And what happens is your number of virtual users here in this third stage is going to be a net decrease from 10 to 1, a net decrease of 9. So this change rate is now going to act as a ramp down rate. All right. So this is how the same change rate value results in both a ramp up and a ramp down definition. Or if you find this concept a little hard to wrap around your head, what you need to do is simply look at the user load preview, and then that basically depicts this whole thing in a graphical manner. All right, so this again is one of the features, one of the out-of-box functionality features that you get out of HCL OneTest Performance, right? If you were to accomplish the same thing with a JMeter test script, and you have to shop around for other plugins, and I think there is a plugin called Concurrent BZM thread group or something, which basically gives you this equivalent view, but you get it out of box with OneTest Performance. And while executing your schedule, there is an important window here called an execution event console. So this basically is a pumps information at real time coming from all the load generating agents, right? So if you want to have a look at a real time look at failures or events that occur that you want to watch out for, this is basically where you look for it, and then know that there is a filtering mechanism for it, so you can basically play around with these filters and get in case you see what you don't want to see, adjust it here, or if it is even if it is vice versa, you can adjust things here. A lot of these things needs a little bit of your own trial and error and exploration, figuring out. There is a lot of fun in that, but it's not possible to cover every single thing in this discussion here. So feel free to explore all of this more. So with that, we come to an end of the second section of our technical talk, the execution part of it. Let's move on with the final section, which is reports. Now, here is the single biggest reason. If you remember the philosophical differences that we came across in the initial set of slides, one of the first differences that we saw was that if you remember, OneTest Performance is a single standalone product versus JMeter is like more of a tool in a larger solution, right? So this is basically one of the biggest examples of that. So if you look at Apache JMeter, if you were to work with the core, again, there is basically no way you can get all your real-time metrics from a performance test run unless it costs heavily for your system and unless you set up more plugins to do it, right? So if you want to get real-time view into a performance test run with JMeter, what would you do? So you would do something like add up a listener for a real-time database like Influx database, and then configure your InfluxDB listener so that all the real-time counter data go into that InfluxDB and sits there. And then you have to have a Grafana installation or some other visualization framework installation on a separate box, and then have that configured to read data from InfluxDB and draw all the graphs for you, right? So there is some amount of, I would say, solution architecting involved in getting this thing right. Whereas with OneTest Performance, you get this whole rich functionality out of box. And the way this is done is through a module that we call the Web Analytics module. Okay, it is made for efficient real-time built-in reporting that you can use while your load tests are going on. Now, what we've also built into the product is a set of canned ready reckoner reporting templates, which organizes all the statistics in quite useful ways for you to do analysis, right? So you get for each protocol or for even each different concern for your performance testing, right? You get a report which is defined for that already for you to work with. So what you simply have to do is on a test, on a report, you can switch between one report and the other using this dialog. So these are all the canned reports that's built in for your HTTP testing and analysis, right? So we have reports for performance, we have reports for the test behavior, and then we have an agent health report too, which gives you the health of the load generation agents that were involved in this test run. The default report for HTTP is the performance report, right, which is what we have open here. We'll get to some more details of this pretty soon. Now, whereas if you look at JMeter's approach, right, as I was telling you, there is no real-time reports that you get out of the core product. And in order to get reports, you have to wait for the test run to complete, have something called an aggregate report listed on added. This is basically another kind of listener that you have to add into your test. And then using this, you'll have to go ahead and manually generate an HTML report, right? And while you're generating the HTML report, you'll have to specify a few properties which has some of your preferences and stuff like that, so on and so forth. So this is basically how you do real-time reporting. I'm going to quickly open up an Apache JMeter report for our test script run that we have here. So once you finish your test run, this is what that static report that Apache JMeter generates for you looks like. You access it with a browser, and it's got some stuff. It's neat. It's organizes stuff nicely. The presentation is good, and all of that things. I honestly like some of these things that I see here. But that said, it's static, and it is something that you need to do a manual step to get generated, right? So that's with the report framework. Now, let me also say this, that the way the reports work with OneTest Performance is that when OneTest Performance, the controller, the workbench opens up, right? Along with it, it opens up a web application for your web analytics reporting. And the load generating agents, when it is doing the execution, once it gets sufficient amount of data, periodically it will dump all of that to the workbench, right? It'll write all of that. It'll give all of that to the workbench. And the workbench will do two things together. So one, it'll plot all that data that the agent sent to the workbench. It will plot all of that into real-time graphs that you see while the test is running. And in addition, it will also persist all the data that it gets to certain files on the file system. So it does both of these processes. It's a web application that runs along with the workbench, and the workbench, in addition to accessing it in the workbench through the workbench viewer, you can also access the same via a browser as well externally. And also similar to what you saw with JMeter, you can export a result that you want to export into static HTML files and then use that for circulation and things like that, right? And the reporting application also gives you a few power use features that's not possible with the core of Apache JMeter. Stuff like you can, I already told about all the CAN reports, right? You can switch between reports and so on and so forth. And it's actually would be interesting for you to know that since you have multiple stages in your virtual user schedule, right? You can use the reporting application to perform comparisons between different stages, right? So you can, let's say, compare, if you want to compare the performance of the application when 5 users were on it versus when 10 users were on it, you can use the same web analytics application to do this comparison for you, to do all of that for you, right? So you can do that kind of comparison. You can filter between, if you have, let's say, multiple load generating agents that's involved in your playback, right, involved in your load testing, and you can filter down based on different sources. So that's again one other power use feature that your that OneTest Performance gives you. So all of these, like, collectively are like built-in tech stack that you need for your performance testing without you having to, go on the tool way and search for technical solutions elsewhere. So all of these, are given to you out of box. So that's with the reporting application. So now we are going to move on to the final section, which is the analysis part. Do a kind of brief time check here. All right. So let's now look at some facets of analysis, right? What do we have to keep in mind now that we know how to generate reports and stuff? So how do we, what are the essential things that we have to keep in mind? So as with any performance testing tool, as with Apache JMeter, with OneTest Performance as well, the key concerns as performance testers for you is going to be 3 separate things, right? The response times, and then your throughput rates, and finally your error rates, right? So any kind of performance analysis of an application is going to involve all these 3 in tandem, and you cannot look at one without the other. It doesn't make real sense from an analysis point of view. Now, that being said, we can look at an Apache JMeter report and see, where we can find these crucial details about your testing, right? So we can see that if you look at the statistics, overall statistics table of a JMeter test run, you can find details about, errors or error rates or error health on the first section, and then you have details about your response times clubbed together, and then you finally have details about your throughput, right? So all of this can be found here, and then there are other charts and tables as well that you can refer to, response times and throughput, and then an overtime kind of thing. It gives you all of this. Now, the same way, OneTest Performance, if you look at, so we are now looking at the default performance report, the HTTP performance report, right? So it kind of categorizes all the data, all the metrics that were generated out of your test run, and kind of bucketizes them into these 3 concerns and put them separately, right? So you have your page performance related detail, right? The stuff that's about response times. So that comes first. And then stuff about your throughput comes next. And then details about your health, right? And then we also have some other handy details over here. And then we have something about errors and health, right? So all of these are basically part of, are organized neatly on that same premise that we just now talked about. Now, the final thing that we want to talk about in detail over here is, so this is one of the features that I want to talk about in a little bit of detail, and that's about response times, right? So this is the single most biggest factor that points to the real world fidelity that OneTest performance provides when you compare that with Apache JMeter. And that is on the way the response times are determined. All right, so we're going to spend some time on that, and let's see. So for doing that, let's now quickly go back to how the test script looks like. Now, if you remember, while we were looking at the scripting considerations, I had told that we are going to look at some further detail of how these pages are going to work and why the page is a transaction plus plus and not a simple transaction as you would imagine it to be. So we're going to spend some time understanding what that is all about. All right. So for understanding that, let us first look at what JMeter does in order to report the response time numbers for this home transaction, right? So the home transaction, as you can see here, is built off multiple requests, and all of them, I believe, are going to be run in one shot, and then all the response times are going to get summated, right? In order to get the final response time. That's what you have in mind as far as the overall transaction time for a JMeter transaction goes. So let's now look at getting back the Apache JMeter report. Let's look at the dashboard main page and let's look at the statistics table, right? So here is our pet clinic home transaction, right? And it's come back with an average transaction time of 58 milliseconds. And that is a sum total. If you look at it, do the math, right? It's a sum total of all the requests that make up the home transaction. So 18 plus 4 plus 4 until this. So add all of that up, aggregate all of that up, and you get 58, right? So the response time for your transaction in JMeter is a simple addition of the response times of individual requests, right? Now, this is like simplistic and maybe appealing to you if you, as a layperson, start looking at the performance of a page, right? But this is far from how an actual browser does this thing. So now let us look at how a browser measures the performance of the same transaction, right? I'm going to quickly bring up the browser window again. Some data. And I'm going to bring up developer tools. And I'm on the network tab, right? So I'm going to launch the application here. Let us see how the browser loads that page. Now, this is actually quite important for you to understand if you were to, know the real impact of. Second. Missed up the view. I'm going to reload this page just to get rid of this and get the clear view in front of you. Please bear with me. I'm going to get this right. So this time it loaded everything from cache. So I'm going to close this, close cache. Okay. Reload. There you go. So this is how the browser loaded this page, right? So the end user's experience of how this page loaded is not how you saw JMeter did it, right? But it is something like this. It's different, right? So if you look at the response time that you got from the browser, it is 126 millisecond, which is quite different from what we saw here as the transaction time for the same transaction as shown by JMeter. right? Now, why is this so? So we need to understand that underneath the hood, when the browser accesses a page, a lot of things happen. So what it does is, it first knows that it has to hit a particular URL. So it goes ahead and hits that, and then it gets back the response. And as you can see, at that time, the browser is not doing anything else, right? It simply opened up one single socket, did the request, waited for the response, and then once it got the response, it seems to have not done anything with the network for some time, right? As far as the network goes, things are ideal in this section. So what happened during this is that the browser was going through the response that it got out of the first request, parsing it, and trying to see if there was anything else that it needed in order to successfully render the whole page. And based on browsing through it, it realized that there are a few a few assets that it needs from the application in order to finish the rendering, right, based on what was on the response. So it looks, while the processing of the response is going on, there's been some delay here, right? And then once the processing is over, it knows that the browser knows that it needs a few more assets to be pulled down from the server. So at that point, what it has done is opened up a few sockets in parallel and then issued all those requests together. As you can see, there was some time when the network was active again, and then some time when the requests were completed, and then the browser again started waiting, and then again the process kind of repeated, right? It realized that it needs some more requests to be, some more assets to be pulled out from the application. So it went ahead, dispatched those requests, so on and so forth. This whole process is inclusive of multiple things. So one is some parallel socket connections involved. There's some requests being dependent on some other requests, and then some brief periods of time when nothing happened, right? So all of this together adds up to the experience that you get as an end user when you loaded up that page. All right, just have that thing in mind, and please do print this image, right? Have that image held on to your memory, because this is going to be important for us to understand, why a page container in OneTest performance is a high fidelity approach in order to measure this, right? So again, to repeat, you have multiple sockets, requests that are interdependent, and then rendering times. So your overall performance of that page is going to depend on all those three factors, right? So this is what a browser does, and the net number that you get, which is 126 milliseconds, is not going to be a sum total of these individual bars that you see here, right? It's going to be the time at which this first request was dispatched and the time at which the last response was received. So that whole time spent is reported as the time taken to finish that page. Okay, that's what your user's experience is going to be. Now, with that in mind, let's come back to OneTest performance, and let's look at all these elements of the script in detail. So at the beginning of your request, the beginning of the page, the first request was dispatched, and that's to the home, right? And this response has triggered a whole set of secondary requests, as we saw earlier. Now, if you look at the socket connection that was used for making this request, it happens to be a socket called connection 25. Okay. Now, if you keep stepping through the rest of these requests, you're going to see that there are multiple sockets, right? So this one happens to be connection 25 again. This is a different socket, connection 26. And this request 2 uses the previous socket. This goes back to socket connection 25. Now, a whole new socket connection has now come into picture. Another new socket connection has come into picture. Right? So you get the general idea. So all these requests are going through parallel sockets, like how an actual web browser does it, right? Requests go through parallel sockets. So you see some sense in that now? Now, the other thing that we talked about is, in addition to parallel sockets, is the interdependency between requests and delays between requests, right? Now let's examine how that is captured into this OneTest performance script. So if you look at the first request and go to the Advanced tab, you're going to see no client processing delay involved, right? That's because this request is standalone. That's basically what started off the string of events. So there is no delay associated with that request. We go to the next one. Again, this happens to use the same connection as the previous one, right? Since HTTP works on the basis of a single request on a socket at any point of time, this implicitly means that the same there has been some wait before this request was sent. And similarly, if you step to the third, you're going to see now that there is some extra delay that we built into this particular request being sent. So this request is going to be sent only after 33 milliseconds after the first request was satisfied. All right. Similarly, if you go and look at other requests, you're going to see this phenomenon happen again. So if you can see the request to fetch this Spring Pivotal logo image has occurred 68 milliseconds after the first request was responded to by the application, right? So all the delays that you see in the browser in between requests being sent on the parallel sockets, right? So that also is captured by OneTest Performance inside the script. And this has happened by default, right? Now try to remember what we told about fidelity out of box, right? Out of box complex behavior. So this is one good example of that. So when you look at a script that was captured by a process of automatic recording, that itself has built in all the level of detail that is there, that embodies performance as done by a browser. All right. So it's not a simple chaining of requests or a simple dispatch of requests in one shot. Instead, it does something which is very similar to what you see here on the browser in order to give you the per page performance number. It's very important to keep that in mind. And also, if you're wondering how this happens, right? So the way this is done by OneTest Performance is by using a feature of the recorder, right? So the recorder kind of cleverly captures not just the actual packets that are sent across the network, but in addition, it also captures the level of detail that is going in between, right? The things like time that is spent between the same socket was used for different requests, and which request went in which socket versus which request went in the same socket after what kind of delay. So all of those things are encapsulated into what you get out of your first test script that you generate out of your test run. All right, and this is basically what you see on the test run is a representation of the kind of events that occurred in the browser while you were recording. Okay, so please also have that in mind, because that's kind of the best approximate that you can get in order to replicate the browser behavior, right? Think of what the browser did while you are recording first and kind of replicate that whole thing out for the script for you. But at the same time, since you used the real-time events on the browser at that point of time when you actually did the recording, whatever kind of things that were going on in your environment that influenced the browser to perform in a certain way, all of those are going to get embodied into that script, right? It's kind of a representation of the browser events as and when you record it. Sometimes that might be a little off from what you have in mind. So what you need to do is step through these requests, go ahead and play with the delays and stuff, and try to get it as close as what you see in the browser, right, through multiple atoms. And in order to do this, there is an easy way to see how this happens. If you look at the page performance, right? If you see, for example, if your page performance, let me open up a simple. All right, so this is a single simple one request kind of thing. So 207 milliseconds is what the page response time is reported back as, and that's kind of close to what you saw as a browser delivering, right? It's a little more than what the browser gave you, but kind of close. It's not way off, right? Now, if you want to see what actually caused this response times, right, you can easily use this view and look at what contributed to it towards that particular page response, right? And then the reporting framework, it gives you a breakup of what are the kind of timings that were involved in each. So for this PEC home page, we can see that there is a connection time contribution of 15 milliseconds, and then a client delay of 176 milliseconds, and the application individual request response time of 60 milliseconds. So this is what basically encompasses the entire page's performance in terms of response time. So now with this, I hope you can see how this is a far closer approximation of how a real world user would basically experience his performance, right? Now there are other aspects to it as well. So if you remember when I was trying to load this, let's see what happens if you try to reload this application, right? So when you load it for the first time with a clear browser cache, you're going to see requests for all of those, right? Now, all the requests are being pulled from the network. But if you reload this page, let's see what happens. So at this point, you can see only the first request was sent to the application server. All the rest of it were pulled from your memory and disk cache. You see that? So this whole thing was cached by the browser, and there is barely any response time involved, right? So the finish time this time around is like quite lesser than what we experienced in the first time. All right. So this aspect, right? So this is something that you may not be able to replicate with JMeter unless you explicitly set up a cache manager kind of thing on your test script. Whereas with OneTest Performance, your page caching is something that is built in by default, right? So this is like a simple playback of a simple test in one loop. So there was no cache that was involved in this, but if you try to run it in a loop, right, then you'll start seeing that the caching also starts mattering. Can't see it for some reason in this, but it's built in with the test script, right? So you have to explicitly disable page caching if you want to take out this emulation. So this is one other example of your real-world fidelity, which is built in to the test script. So with that, I think I pretty much come to the close of whatever I had in mind to talk about in this session. So what we did in the session is we kind of reviewed certain key differences that are there between these two tools. We attributed them to certain philosophical differences between these two tools. And then with that way, we kind of reinforced what those differences are in terms of the central ideas that are to the core of the tool, right? So we were talking about when we started off certain elements of friction that could exist when you start, when you encounter any kind of new change, right? So what I've attempted to do with this session is to basically try to eliminate some of those friction points, right? So that your further continued journey of exploration with OneTest Performance becomes more rewarding and exciting. So with that said, I want to thank all of you for your patient ear, and I wish all of you happy testing. Thank you so much. We can open up now for questions.
Thanks, Arun. Yeah, I'm going to go ahead and unmute everyone, hopefully. And then if you have any questions, you can just go ahead and unmute yourself and ask away. All right, you should all be able to ask questions now. If for some reason you can't, go ahead and type your questions in the question panel, and we can read it out loud. All right, I don't see any questions. I don't hear any questions. We will be sharing the slides and the recording. Oh, here we go. We do have one question. All right, Arun, they're asking, how do you identify a particular call is taking most time? Arun, I think you went on mute.
Unmuted.
So there is a report that you can see each individual request, and we filter that based on, like the top 25 failures. So I think Arun is showing that. Arun, are you able to speak also, or?
Yeah, I can now. I was not
Okay.
able to unmute myself.
Thanks, Don.
Yeah. So did that answer the question? I suppose so.
They're not saying anything else, so I'm assuming that answered the question.
Yeah. Yeah. In addition to what Don was trying to say, I think you can use, so for example, if you look at this request here, right, the find owner page seems to, this is actually a good use case for us to consider this question. So the report, the response time has been reported as a kind of a huge 4.962 seconds, right, which is definitely not what the browser did. So we want to understand why this happened. So if you look at the response time contribution for this page, so what you do is, yeah, so this is the view that I was showing you earlier to the session. So you basically see that the entire response time that has been reported is like almost allocated to the client delay, right? So that's definitely something that you need to adjust. So I don't think 4.931 is like an accurate delay that the browser is going to experience, right? So there is something off with that particular page. So what we should do is then look at that page, look at what are the requests that are underneath it, right? And see which request is causing that delay. And the last one doesn't have any client delay associated with it. It's not that. And if you look at the second request, look at the client delay of it, you see there is a, so this basically is a request that has contributed almost entirely to, you know, that response time that you saw for the find owner page. So modify that and you're good. So what actually, this is a special case. So what has happened is, in fact, instead of a single page here, right, this basically is like two separate pages. If you remember what the scenario that we were looking for is, so you clicked on the home page, you brought in the home page, and then you clicked on find owners, which is like a different navigation, and that brought a separate page in front of you. And then on that, you added the user. You added the user that you want to find, right, on the form, and then you hit find. So this is like basically two pages which are clubbed into one with some kind of think time, which was here in this, but we kind of captured that think time as a client delay. So what we ought to do to fix this is to basically set this up as, you know, a separate page, split it up, and then there you go. So your find is now a separate page, a separate transaction. I'm going to name it differently, and your find owner is going to be here, right? Now I'm going to modify. Look at the this is gone. You got that. Wait as your think time now. Like the tool automatically cleverly got that, right? It automatically put a think time. So now if you play back this script, you're going to get a totally different response number, right? So yeah, so the fundamental idea is to look at the response time breakdowns and, you know, figure out what is actually causing the delay and address it. If the response time contribution is not due to client delay, and if it is due to individual responses, right, you can either look at it over here itself. Sorry about that. You can look at it in the performance report, enabling page response time contributions, and you can look at it here, or you can switch to the page element performance report and then view the details over there, right? So two different options in front of you.
All right, perfect. Thank you. And then we do have another question that says, is it good practice to minimize client delay processing if we see this at a higher side during analysis?
Right. So my take is that, yeah, you shouldn't go blind at it. So my take is that look at what the browser does, clear the cache, load the page or the scenario in your browser, and look at what the browser does, right? Because that's what an end user is going to experience. Maybe do it a couple of times and look at the kind of delays that are involved between requests, and then try to replicate that in your script. That's my take. Scott, is that Scott and Don, you want to add something to it?
You wouldn't want to blindly just say, well, let's just make them all small to make my response times lower. because doing so may inaccurately reflect the true application does. But as Arun was showing there a minute ago when he was doing the page combination example, sometimes the way the script is built will lead the numbers to be higher than they really should be. And in that case, you would want to knock them down.
Yeah, thanks, Scott. So yeah, let me also add that if you want to knock that entire client delay to a bare minimum 0, right? So what you need to do is to go at the test level. And again, this goes against what Scott was just now telling you, but just for your awareness, I'm calling this out. You can simply slide this page to the minimum, and that basically, that is a kind of a friendly reminder that decreasing this is going to cause playback problems in some applications that you need to be aware of. So don't blindly do this, is what you're trying to say. So yeah, so you can do this here in one shot, but again, it is still not equivalent to what a JMeter transaction controller is, right? Because the JMeter transaction controller by default throws out all the requests in one time, whereas there is still some kind of sequencing using the same sockets that's going on here, parallel sockets. So if you want to take that out as well, which I would strongly recommend not to, you want to modify the connection that's associated with each request pointed to the same one socket connection, or make all of them different, right? Ensure that you have different sockets for different requests, kind of thing. So all those kind of things are possible.
All right, perfect. Thank you. I don't see any more questions, so I think we are good for today. Arun, thanks so much for putting that together. Appreciate all your hard work. And
yeah, it's been a pleasure. Thank you so much.
Thanks
to everybody.
And thanks to the team for joining the call to help us with the questions. As I mentioned earlier, I will be sending out the recording and the deck a little bit later today, possibly tomorrow. So please keep an eye out for that. If you have any questions, feel free to reach out and I'll be sure to connect you with a member of the team. All right, thanks everyone. Enjoy the rest of your day.